I'm Jerry Tuttle, University of Phoenix. This is not my picture. I've never looked this pretty. But this is the Aunt Sally of PEMDAS fame. When everyone talks about PEMDAS, this is the Sally they're talking about. But we need order of operations in English as well. So for example, when the lady hit the man with the umbrella, who had the umbrella? The lady or the man? Rachel Ray finds inspiration in cooking her family and her dog. Very tasty. And did the lion eat Fred? Or did the lion eat Fred? There are other order of operating systems besides PEMDAS. If you've ever had a Hewlett-Packard reverse Polish notation calculator, remember those? There's no parentheses, but the user forces the order. Here are some other ways to describe PEMDAS. I like, please email my dad a shark. People expect more drugs and sex. The Brits like BODMAS, brackets, orders, devices. Many students seem to have an awfully weak understanding of PEMDAS from high school. They've memorized it, but when it comes down to it, they really don't know what it does. That does basic of order operations well. Even the Google search field does a pretty good job. Of course, Wolfram Alpha does. Excel does not do as good a job as you'd think. Many students ignore the equal precedence feature of the M and the D, and people will do the division second, even though it's equal precedence. Excel gets this right, as do most technology. Try this one. The divided by symbol is called the obulus, but it's not a grouping symbol. And I think you do that 1 divided by 1 first, and therefore get that answer. Is it possible that people will interpret the D and the A in such a way to do 12 plus 9 divided by 4 plus 3? The horizontal bar has its own name. How about stacked exponentiation? Is this left associative or right associative? Many authors think it's right associative. Excel gets this one incorrect, but we all agree on the integral. No one's confused by that. Concatenations. In this context, this means omitting the operation symbol. The additive inverse of the square of 3. Many people get this one wrong. And how about additive inverse of mixed numbers? Functions are not addressed by PEMDAS at all. Sine of x squared is confusing to a lot of people. If you forget the parentheses, what do? That sign with the -1 certainly causes confusion. And where does the n factorial fit in? The slash symbol. I'm often pretty careless with AB over CD. PEMDAS would tell you to multiply by the D. But one journal says the slash has its own precedence. Here's the summary of some technology, including photomath. Many people have photomath nowadays. Google does well, Wolfram Alpha does well. Excel just doesn't do as well as I thought. Here are some improvements from PEMDAS. I've spent a lot more time with the grouping symbols. I've added the unary operations. I still haven't figured out how to get functions into this. There's a great video by Minute Physics who says we don't need all these rules at all. All you need to do is use grouping symbols where it's appropriate and understand the math. So here's our beloved Aunt Sally now. In fact, she was just 70 this week. Yes, PEMDAS, like Aunt Sally, is getting old. So let's not expect PEMDAS to do too much. There's a lot more to order of operations than just PEMDAS. And in conclusion, would anyone really multiply 25 times 13 times 4 when you can commute the 13 and the 4? So sometimes it's more efficient to just ignore the rules, even when they work. Here's and the one item I really liked is the problem with math is English, which has a whole chapter on order of operations. Thank you very much.
For two of their campuses. campuses, Owings Mills and Hunt Valley. And I support a lot of adjuncts under my charge. For CCBC, we have 40 full-time faculty members, but 120 adjunct faculty members. So when I do the hiring for all of CCBC, and we've worked really hard in recent years to try to support those adjuncts in more improved ways. So for example, for new adjuncts, they're all required to attend a faculty orientation session. And then in addition to that, there are ongoing sessions for trainings. Semester to semester for new and returning adjuncts, we have semester kickoff meetings just for adjuncts where they can meet. And we also hold a yearly adjunct conference. In addition to these activities just for adjuncts, whenever there's a full-time faculty meeting, the adjunct faculty are always included on those invitations and reminders about full-time faculty meetings. They're not required to come. There's only one adjunct faculty who's required to come to full-time faculty meetings because he's agreed to serve as the full-time faculty to adjunct liaison. After the faculty meetings, he creates a report of that meeting. We try to give pay for adjuncts if they attend trainings, even right at our home campus. If they attend some sort of professional development, we try to, or training, we try to pay them for those trainings. Each adjunct is, especially in the first year, it's matched with a full-time faculty mentor. If that doesn't work out because of timing, we pair them with an experienced adjunct mentor. We try to provide clear expectations for our adjuncts. We have lists of what they need to do each semester. We have common course outlines, and we have templates in Blackboard that they have to follow to make their job pretty easy. And we try to keep them well supplied. We send out emails, do you need overhead markers, do you need calculators, and so forth. Since we have a lot of adjuncts that teach in offsite programs, this is really important. I even send things out to home addresses if they're teaching at weird locations. We send out regular communications once a month, just with important information, sometimes even more often than once a month if reminders about important dates and so forth. And we've just worked and gotten approved a paid day off for our adjuncts each semester. And although it's supposed to be for sickness, we don't really require them to provide documentation for that sickness. So it's really for any important reason that an adjunct needs to take a day off. So we observe our adjuncts every 3 semesters, and it's formative that we meet with our adjuncts after the observation and talk about methods for improving their instruction. And it's all towards promotion because we've established 3 pay tiers. We have a good salary. We work really hard on getting increased salaries. It's about $800 per credit, $900 per credit, or $1,000 per credit, which isn't bad. And they can be promoted by having good faculty observations and professional development. We're also considerate with our scheduling. We ask how many courses you would like to be assigned, and we try to back those courses together so that adjuncts don't need to travel back and forth to teach classes. It doesn't always work. We are very thankful to our adjuncts, and we say that at the end of every email. Thank you for the service that you provide to our college. We really appreciate it. We also have a formal recognition for some of our adjuncts. We have longevity awards, and for instructors who've taught 5, 10, 15, or 20 years, they're celebrated with a banquet. And a little gift that has not much monetary value, but is appreciated by the adjuncts. And then every department at CCBC is, and every campus, is able to put forth a name of an adjunct who receives an award for their department and their school. So, and on my campus, this is something that I do. I buy little individual pies, they're about this big, and I keep them in the refrigerator on my campus on Pi Days because they're there at all times of the day. And if they don't teach right on Pi Day, they probably teach the next day. So, and this is because they're so important to us that we could not survive without our adjuncts, and we like to keep them from semester to semester. Thank you.
So my name is Mike Long, and I teach at Howard Community College in Columbia, Maryland. And I like working with pre-service teachers. I like doing the Math for Teachers courses, but most of all, I like doing number theory. So we're going to do some number theory in the world's fastest math magic show here tonight. So I need some participation from all of you. If you would, write down a 3-digit number with no digits repeating and find the sum of those digits. I doubled these slides on purpose, that way you had some time. Yes, this is permutations. Yes, this is combinations. It's a little of both. So you could even do this in your class. So once you write down those 3 digits, find all the possible combinations of 2 numbers that you can. I know. I'm going to ask you to do math on a Friday night. Isn't it fun? Anybody got it yet? Anybody got it? Anybody got it? Nobody? Nobody? See, I told you this is going to be the world's fastest math magic show, which requires the fastest participants as well. If you had done what was up on the screen and found the sum of all 6 of those numbers and divided by the sum of the original 3 digits, you would have found the number 22 at the very end. Now look at this problem. It's nothing more than collecting like terms. If we're a group of mathematicians, you could do this in a developmental math class. So with that being said, let's move on to our second trick for the night. Remember, I said this is the fastest math magic show you've ever seen. You need 3 dice. Most of you don't have 3 dice, so write down 3 numbers. Make it between 1 and 6. That would be a good thing to do. Pick one face, multiply the value by 2, add 5, then multiply by 5. I know a lot of computation here tonight. Add that value of another face, multiply by 10, add the value of the last face, and tell me the number.
7.
7. That won't work. Something has been done mathematically incorrect. Yeah, did we match? All I had to do was subtract the number 250 from the number that you gave me, and believe it or not, I'd have the numbers on all 3 of your dice. How do you like that? Now, how in the world does that work? Well, again, it's simply something we could do with our students, actually. We're just going to collect like terms. It's writing algebraic expressions, it's putting things together. Notice that next to last line, subtract 250. That's all I had to do. It's pretty easy, but I probably still would have used a calculator. And I get 100x plus 10y plus z. And we move on to the third trick, where we write down 2 one-digit numbers. Yes. And we start adding them recursively. I love this particular trick because it involves the recursion of the Fibonacci sequence. Everybody say ooh and ah with me. Ooh and ah. Yes, the Fibonacci sequence is involved. The cool part, though, is you got to walk by. I did put some props on one of the tables, but they're not playing along. That's all right. Once you get to the 7th number in the sequence, I need to know what that is, because I'm going to multiply that number by 11, and here's why. Notice at the end, this would have been a really big task for you to do. Determine the sum of the 10 numbers in the sequence. That's adding 10 numbers. I know that's getting pretty sophisticated. I did have some calculators over here, but do the paper and the sum match? What's going on with that? Well, if you add up those 10 numbers in your sequence, yeah, that's 7 times 11. 11 times the 7th number in the sequence, believe it or not, they're actually the same. Look at this mathematics right here, ladies and gentlemen. Adding up all of these variables, quite a famous trick. Love doing it. Wows the audience every time. I hope it wows you as well. Thank you very much. Yes, I appreciate it. And we move on to the 4th magic trick of the night. This one involves a really special number. So everybody write down a 3-digit number with no digits repeating and preferably no zeros, because that makes the trick a lot harder for me to do. Trust me. Swap the digit in the hundreds in ones place. Now subtract the larger from the smaller. I know it's getting really complicated. You should have a scenario like that. So you have a new 3-digit number. If your difference only has 2 digits, put a 0 in the hundreds place. Do the same thing you did before to that number. Swap the hundreds in the units place. And then add those 2 numbers together. Believe it or not, everybody that did that, and I can tell you all did it, because you're looking at me and you don't have any pens in your hand. It feels like I'm teaching my classes some days. Do we all relate? Anyway, everyone in this room would have wound up with the number 1,089.
I did.
And we did. Thank you very much for playing. I don't have any prizes, I'm sorry, but all this is simple subtraction and regrouping of digits. Something that, you know, we did since 3rd grade, but wow, down there in that bottom right corner is the number 1,089. That's the number that you all should have ended up with. Think about how you can use some of these tricks in your classes to engage your students and to enlighten your students. Until the next time when we do this again, don't forget mathematics is fun, mathematics is great, and have fun doing mathematics most of all. And a little number theory too. Thank you.
It's not working anymore.
Hi. I follow that. I have no tricks, but I do have an AMATYC board. And you're going to meet them up close and personal. Aren't we just excited? How about who are we? You can read. The first 1, 2, 3, 4, 5, 6 are the actual board. But we love Wanda Garner and Kevin Doctor, so we include them as the executive director and the conference coordinator. This Ignite presentation is a combination of what we did at the Strategic Planning and Orientation meeting in January. Everybody did 4 slides, I picked a slide. There's a fun side to us as well, and we want you to become part of us. So we're going to begin with me. Okay, you see a log cabin, that's what I live in. We just got high-speed internet, and my town has no traffic lights. So I live in the sticks with a 700-foot long driveway. That's my family. Now it's Jim Ham. He's the president-elect. I don't know what he's doing kissing a fish. I have not been there now. He's obviously, family is pretty important to him. He loves to travel. He's a great guy. Looks good in a suit. Nancy Sandler. She's here someplace. She's right there. She loves to quilt. She loves her family. I love her daughter. She's helped me out immensely this week. She makes cookies at Christmas time. She brought jam to Germany and gave it away. Michelle Duda, I'm sure she's here someplace. She loves sports, mainly Ohio sports. Sorry, Cubs, that was great. David Tanner's my son. If you do notice, the Tanner spelled a little bit differently. People originally thought he was my husband. He was too young. I did marry younger, but not that much younger. That's what he feels like when he's a treasurer. Oh my God, what did I get myself into? We next see the Ernie Danforth. That, I think, does he look like Elvis in that picture? That's when he was at the community college. Well, he still is. His family, he loves to sing. His grandchildren, he likes to golf too, but he didn't put that on the slide. Oh, Dan Farmer, I don't know, he's back there, he's grinning. He thinks he's the sun god. He can marry people. His family's important. He's a coach. He tells me what to do all the time. I move him out of order in the board meeting. Nancy Rivers, Southeast Vice President. She has lived in all those places. Grandson. She loves her grandson, her family. She's riding a bull, so they dared her to her. It's not a real bull or steer or whatever it is, but she had to do it. John Oates, oh my God. Taco Tuesday, that's his favorite. Taco Tuesday, he always posts it on Facebook. That's his home. These are basically the only pictures I can get off of his slides. That's his home. He loves the Detroit Pistons. We went there on Saturday night. Nicole Lang from Minnesota. She loves her daughter, and she plays the flute, and she likes those wine and draw parties or whatever they are. She does that. Ask her about calculus camp. Kate Kosak, we're really glad Kate's with us. She's standing back there. Kate, this is for you. I don't even want to use my 15 seconds to talk about you. She's fantastic. Sport person, loves to ski, loves to bicycle. Her bike is okay, she learned. Liz Hilton, West VP. She has a dog. We hear about the dog a lot. Her husband, her daughter just got married. That bowl her students made out of tessellation of fish patterns. That means a lot to her. She likes to travel to Europe. We enjoy our time with her. Mark Harbison, West VP, he's over here someplace. He took his daughter when she graduated from high school on a 9,000-mile trip around the country. You can see where it is. Frisbee golf, he's into that. I assume that's what that is. Wanda Garner, Wanda's been godsend to me. I hope she's in here. I think I saw her. She loves cats. I'm not sure if it's that the 30-pound cat or not. She said yes. And she texted me that picture because she knew I would appreciate it because I like cats too. Kevin Doctor, the conference coordinator, wave hi, Kevin. When you see her. He likes to bicycle. I think he rides motorcycles too. He goes on mission trips. He does a lot of good. We are a family. If I could sing, I would start singing, we are a family.
Sister Sledge.
That's all I know. That's my son. This is just a great bunch of people to work with. And I would like to encourage you to, this is all the VPs last year in Nancy Sattler's tub that she had. This year, they all slept in my bed. Don't even ask. But we encourage it. It's a great board. We love you all. Thank you.
Hey, I'm Barb Berlowski, and I started the tequila tradition. So I'm going to talk about California community colleges. We have an online ed initiative. The idea is that we want students to actually complete their degrees and transfer. How novel. And so the governor decided who would give us money. First, he decided, Governor Brown, that the solution to everything was to have all of our pre-transfer level courses all be MOOCs. And then we said, no, 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 no. So he started the online ed initiative, giving the colleges money. We're teaching faculty on how to improve online learning. We have ADA compliance. We're getting students, so if they're at one college and their college doesn't offer the course, oops. So here, I decided that I was going to do math across the curriculum in all my presentations. So I've now taught everybody what a Venn diagram is in California. We have the colleges like Fred's Coastline, which is using all the resources. We actually have had 98 colleges now say they're going to switch to Canvas out of 113, which the whole point is it's not that it's Canvas, is that we're all using the same course management system. They were incentivized because we said, we'll pay for it if you want to switch, so schools do. So I'm cheating on this slide because I have it twice, so it's 30 seconds. We allow, and we have online readiness modules on how to take online courses, library services, proctoring and plagiarism services, accessibility support, universal design, because that's the hardest thing for faculty is like we may know math, we know our subject, but we're not experts in ADA compliance, and that's the only thing we have to legally do is do ADA compliance. We have tutoring online, embedded support for students, and equity is a really big deal. So there's equality and equity are not the same thing. Equality is everybody gets the same thing. Equity is everybody gets what they need. So here, this is a cute little diagram to reach the apples. Everybody gets an apple and everybody's happy and healthy. So for professional development, what we've done is we've developed a set of rubrics working with California community college faculty from around the state. We actually have 63,000 community college faculty in California. Of course, most of them are adjuncts, but 22 are full-time. And we're working on teaching them one Canvas, but then as we teach them the little parts about Canvas, we're sneaking in pedagogy. So they don't even know it. They've signed up for this free course and they get pedagogy in there, and we're helping them to develop their courses. The online readiness modules are things like how you be an online student. For example, you can't just log in once a week. So these are modules for students on how to learn online, which is different than orientation to college. Okay, academic integrity, we're doing online proctoring now, so students can have proctored, and it's really cool because it does things like, if you look down between your legs too many times, I'm thinking of looking at people passing through the answers, not anything perverted. So, there's a way to do it. We have online tutoring 24/7. We subscribe to NetTutor, which is out of Tampa, Florida, and they provide 24/7 tutoring, and in math, it's in English and Spanish, that you can get the tutoring there. They also have paper centers. It's free for all of the schools and the pilot colleges. Worldwide whiteboard, I hold my office hours using the whiteboard. The students come in. I thought they would want to do the audio and video, but actually they want to write to me. And so that's okay. They're in the chat room. They're doing writing. We're working with the National Tutoring Organization on this. Here's an example. Oh, Jane Suze, I don't know if you're here. I'm highlighting one of your videos. If you are, wave your hand. And so, for example, if you're in economics class, we're doing basic skills because usually people have problems with the math, finding the equilibrium point, not actually knowing what it is. Psychology, here's an example from OpenStax College. Go visit the vendor. That's free open education resources out there. So if you're in a psychology class, this is actually from a psych book trying to find out how many standard deviations above the mean an IQ of 130 is. Well, you could go to the textbook that I happen to write. That was really good. We have online counseling, and students can actually get counseling appointments with their community college counselors who are discipline experts, but they're being trained in how to do counseling online, not how to be a counselor. We're using a platform called Cranium Cafe, and again, free for the California community colleges. You can do online drop-in sessions and so on. Long slide. Come on. Why are you moving? Okay, we're also working with online library resources. Oh, it's right here too. Okay. So you can get resources for online library for taking online courses. Because the idea is if you're taking a course online, you should have the same services as if you're taking a course on campus. And we have an exchange. So if you're on campus and your college doesn't offer the course that you want to take, you can take it at another college. Your financial aid transfers, your full-time status transfers, and all of that does. And it's really great, and contact me, I'd be glad to help you, and I'm done.
About professional development, which is kind of weird because we're at professional development, so maybe I'm just preaching to the choir. Well, you're at beyond the crossroads. Who will go ahead and lead us? Who will be that next person to lead us to the next direction? Well, I would like to nominate one person. Do you know who I am going to nominate? It is Vanilla Ice. Now, you're saying, why would a stereotypical white male, a celebrity, a pop star who has no math education be able to lead us in this direction? I don't know, well, maybe he has some good ideas. I bet he could make a great slogan, let's make mathematics great again. Well, you know, sometimes even if it's not broke, we like to fix it. So people like just fixing things. Well, let me tell you how great Vanilla Ice is. Let's just look at some of his lyrics. Well, just imagine if Vanilla Ice went to the car dealership. Sir, here we have a 500 Benz. No, that's one significant figure. Do you have any two significant figures? Oh, look at that 5.0 over there. I want that ride. Let me get inside of that one. So he must obviously be an engineer. Something grabs a hold of me tightly. Dark energy, gravity, flows like a harpoon. Vectors, okay, daily and nightly. A sinusoidal function. Clearly, he loves physics. Can't you see how mathematical he is? Oh, just imagine if he was in the classroom. Class, yeah, I have a problem. Ooh, I'll solve it. Please, me. Can't you see how great Vanilla Ice would be for professional development? I mean, we could just see that if, check out the hook. We all know that a great math lesson needs a hook, something to grab their attention. But who is the DJ? And what is he revolving? Maybe around a unit circle, but who could this DJ be? I'm thinking of a president. Who could that president be? Oh, Dunham Jackson from 1926, MAA president. Awesome person approximation, orthogonal polynomials, great trigonometry work. I mean, you can clearly see how Vanilla Ice is really capturing the mathematics. Well, in 2025, we have a common vision. All right, stop, collaborate, and listen. AMATYC's back with a brand new vision. This is 5 people coming together, but what will professional development look like? Are we just concerned about the education? Quick plug about my conference coming up. I am AMATYC president. We have a conference coming up March 9th through 10th. I want people to collaborate. I want people to come together. But how are they coming together? Is it that you just have like a conference coma? Do you treat this professional development like it's a Thanksgiving dinner? Do you just say, oh, PD, and you just like, I get back? What did you do? I don't know. I don't have time to do anything. We need to break free from this. Do not get the conference coma. Treat it like a compound investment. Just don't do one thing. Start little increments. Let that be a daily thing and just compound on it daily and daily. If I were to ask you, what does your professional development look like? Does it look like this? There's just one spike of the curve. You're like, oh yeah, this is good. What happens for the rest of your spring semester? Screw it. I don't have time for this. I just can't wait for the summer. Well, you take this professional development with one spike and say, oh, I will. No, I can't. Oh, I will. You're just up and down. Boo, this is scary. This is a paranormal distribution. This type of professional development is scary. We need to break free from this. Now I see teachers talk about, oh, my students have a calculator crutch. If you take this calculator away from them, they can't solve a problem. They don't have the answers. They don't have the mathematical understanding. Well, I'd like to challenge you. Is your professional development a conference crutch? If I remove this conference crutch, can you solve problems? Can you get answers from other people? Will your professional development fall flat? What I suggest is that you look at all these people around you. They will go ahead and lift your professional development curve so it's a uniform distribution. We need to be talking to each other and bring this up so there is no longer a spike in the curve. I say collaborate with a grade 58, 5 days a month, 8 minutes a day. Small increments. We do not need these big chunks. Let's turn PD into professional discussion. Instead, I have created a Slack channel for my AMATYC representatives. We can go into here. Just say, hey,
this is what I did today. I really don't care if you like it, but this is just right on thing. Let's make PD automatic, all right, so that we can just do this daily. And so what we need to do is just stop, collaborate, and listen to each other.
I'd like to honor the people who've collaborated with me and have inspired me over the years. Going back to 6th grade 50 years ago, Sister Gemma was did the new math and got me first interested in mathematics. And so I'd like to honor Sister Gemma. In high school, I had a very interesting 9th grade teacher, but junior and senior year I had a fabulous teacher, Alvin K. Funderburg, who got me involved in calculus and computers and doing math competitions and got me ready for college, and for Ephraim Armendariz at the University of Texas at Austin, who had me read an article from the American Mathematical Monthly and come to his office and report on what I learned from reading that article. A little bit of a challenge. Also had MA President Leonard Gilman as an undergraduate, and he had me write homework on blank paper in black ink to produce proofs. Then I had a more method course from Mike Starboard, many of you may know Mike, and he had me present proofs at the board and got me involved in very active learning styles as an undergraduate. As a master's student, Bill Eaton opened up the world of geometric topology and doing research. Half of my graduate hours, 18 hours, were with Bill Eaton, who was my advisor. And as I was finishing my master's program, Joe McMillan hired me at North Harris County College, which is now Lone Star College, the largest college on the planet or something like that. We had 3 people in the math department when I was hired there. Bill Guy got me interested in applied mathematics, and after doing all this geometric topology, and I was thinking seriously about getting involved in doing a PhD in applied mathematics. I was starting at Austin Community College. Some of you may know this guy. He was the president of AMATYC, and he got me involved in AMATYC and classes at our Rio Grande campus so that I could bicycle over and take my PhD classes. And Glenadine Gibb, former NCTM president, was the one who talked me into the PhD in mathematics education instead of applied math. She also put my feet to the fire on learning theory on my oral exam. Ray Carey was my supervising professor, one of the 4 people who got their PhDs from Ed Beagle out at Stanford. And he was the one who introduced me to Alan Osborne, who was my mentor as I began my career after my PhD at Ohio State University. And he introduced me to people all over the country and got me going on grants. Frank DeManna got me involved in writing textbooks in the Calculator and Computer Pre-Calculus project, along with someone whose name is almost always goes along with Frank, that of Bert Waits, who unfortunately passed away a couple of years ago. A great guy who taught me to dream big and was a great inspiration to me as far as technology is concerned. Jim Schultz was another one. I had lunch with these 4 individuals, Alan, Bert, Frank, and Jim, at the 86 NCTM meeting, and I talk on a regular basis with Jim, who is my predecessor in my current position at Ohio University. Joanne Leitzel I also met during my Ohio State years, and she is now back in Ohio after being presidents of universities and provosts and so on. She's a great friend, and she continues to prod me along in my work. I had the good fortune of getting to know Lynn Steen, doing some committee work 20-25 years ago, collaborative working as the AMATYC representative on a national committee, and within the last few years, I've gotten to know a fellow native of Belleville, Illinois, Tom Butts, who's a wonderful problem poser, and he's a collaborator with me and co-authored my current work in quantitative reasoning. So John Wesley says, do all you can, by all the means you can, in all the ways you can, in all the places you can, at all times you can, to all people you can, as long as ever you can. Thank you.
Okay, so my name didn't show up. I'm Pat Riley from Hopkinsville, Kentucky. We got a little Kentucky group over there, and they're all eating pizza and not listening right now. Cheers! All right, I want to share with you an example that I actually got from the Austin conference. Woo! Boy, the glittering is back
Invisible
there.
ink.
At the Austin conference, I attended a session called Math CSI Forensics in the Mathematics Classroom. And at the time, I was working with our criminal justice program coordinator, Mr. Greg Bridgman, and we were working on putting a class together for his students for math concepts, and I got some ideas about speeds and skid marks and things like that. And then one of the other interesting things was blood spatter. So when the criminologists come to a crime scene and they see blood spatter, based on the shape of the impact, they can calculate the angle which the blood entered at. And so there's some examples here. And if they get enough data, then they can kind of get a rough average and figure out what happened. Where did the blood originate from? And that helps them to recreate crime scenes like that. And this has been on the show CSI. They've done examples with that. And so what happens, just real quickly, if the blood drop comes in, when it comes in at this angle, the width doesn't change, but as it hits the ground, it kind of skids and makes an impression. And as you can see at the bottom, if you draw a good sketch, you get a nice right triangle there, and bigger. The angle would be of impact down in the bottom corner, and so the opposite would be the width of the blood drop, and then the length of the blood drop would be the hypotenuse. So we've got a nice little sine calculation here. So if it was 18 millimeters by 4.4 to an inverse sine, that drop came in at almost 24-degree angle. Once you can figure out the angle it came in, then you can figure where it originated from. So if you have a drop like this that was found 60 feet away from the major pool, then you can set up a little problem, calculate that it must have been 30 feet high. So I do this in trig, and then I give the students an assignment where they have to create their own liquid drop. I don't make them do blood. And so here's an example. A student did one with a paint drop, so he's measuring the length and width to figure out where the paint came in. And then I started noticing this in many other places. So if you're in a big rainstorm and the rain's hitting your windshield, very briefly you get a nice ellipse shape, and that's not my car. I couldn't take a good picture while I was driving in the rain. Then I started noticing elsewhere, like spotlights on the side of a wall, or if you see a logo in the middle of a court, or the light fixture up there. That's a really nice one right now. So I started noticing these all over the place and thought, where else could I use these? Well, I was sitting in traffic one day, and I was behind another car. We were at a red light, and I just happened to catch my attention what I saw on the back of the car right in front of me. And if you've read the pink sheet, you know what's coming up. I noticed a whole lot of bird droppings on the car. And when the bird droppings hit it at just the right angle and the right consistency, I guess, it makes a nice little oval shape. And I said, well, that'd be a good example I could take to the classroom. So, I didn't take that example to the classroom. And so if you kind of ignore the little spread off to the side, you get a nice little oval, and you can do some measuring. And I just want to pause here and say we've got a world-class maintenance staff at our college, but I was able to catch this one on campus before they got to it. And I had just covered it and talked about it in the class, so I said, look, here's a perfect example of one. So then this kind of, you can elaborate on this. So there's the side, get the length and the width, you get it coming in. 28-degree angle. Then I started thinking, well, this wouldn't be coming in on the ground. This hit a window on the way down. So then you've got the bird flying in the air. And so you figure there's a nice 28-degree angle. So if you knew how high the bird was or where it was flying from where to where, you could calculate how high he was, maybe how fast he was moving. There's a whole lot, opens up a whole lot of doors for things like different things. Well, I'm telling the class about it, and as students always want extra credit. So I said, if you can find a good example of one of these before the next class, I'll give you some extra credit. And the next day, which was not when we had class, a student stopped me in the hall, and Mr. Riley, I just got to tell you, I was out driving with my family, and this big bird just jumped right on the car, and I said, stop, I got to go mention this because I want my extra credit. So she got her extra credit. Thank you.
Good evening. My name is Manisha Foster. I'm from Southeast Technical Institute in Sioux Falls, and I'm going to share an activity that I do with my students called Every View Has Value, and having to do with the 4 views of a function. So it's a low-tech activity. I have one of the copies right here in my hand. Focusing on those multiple representations, the words, the equation, the table, and the graph. But then I learned that I need to extend it a little bit further and challenge students not just to match up the views, but to extend them into some connections there. So I use this in a college algebra and a pre-calc class. It's the terminal course on our campus, but it comes at the beginning of an intro to functions unit, kind of follows the basic trajectory of a college algebra course. So my students can generate a table of values given an equation, and they can generate a graph given a table of values. Now we've done kind of a general activity about graphical representations of some various scenarios. So they're familiar with the pieces. So I have them work in small groups at tables in 2 to 4, and I have them first sort out some cards. They're different colored that have each view on them, and there's 8 different scenarios, and then they have a set of related questions to go with them. So some of the scenarios, and I realize this is tiny, it's a larger room than I was expecting, but about half of these have to do with some linear functions, which is what we've looked at a little bit, but then I also have to do with, there's a quadratic and an exponential. I'm just tapping into some somewhat common situations. So they start out with their cards kind of in a messy pile and kind of staring at them and what do we need to do with them. And I start to see students, they pull out one of the views or they start organizing them by color. It kind of depends on the group right here as far as what order they go about, but a lot of times they piece together the equation and are not necessarily that, but the situation, the graph, I see that go together, and then the equation and the table start fitting together, and then they kind of get it all together. So setting this up, I'd recommend a different color paper for each view. I've got my little bags, and if I was ever organized in time, I would laminate them as well, but they aren't at the moment. With my table, I try to pick pretty strategic values. I like to include various types of functions like I mentioned before, but also some common situations, but then also challenge them and take it a step further. And I ask them to avoid technology for this particular activity so that they have to struggle a little bit and just don't go right to those graphing calculators. It takes them about 20 to 30 minutes. And I used to stop at that. But then I realized it wasn't really doing anything for us, and so I needed to take it a step further. And so this is the solution. It's the activity grid, and after I kind of go around to each group and figure out if they have any questions, then I provide them with that grid. It's helpful for checking their work, and then if they don't have a time to finish the question set, instead of trying to take all the cards or grab a picture quick, they can just take that with them if they're in a rush at the end of class. So these are also super tiny, but I have this question set. Some of them ask specific questions, and so it's like leading them, if sometimes they can find that view on the equation or on the table or whatever view, but I ask them to tell me the answer as well as the view they referenced, and then why they picked that view. Then I get into more of sometimes it's more of an observation. So why don't the equation and the table match for everything? So we can talk a little bit about domain restrictions. If you get 2 movies free, well, you're not going to pay -$5 or something like that. And then comparing some different questions there. And then I always like to tie it up at the end, like when would you use each of these views? And then what did you learn from this activity? So I found by extending to this question set then, students were actually analyzing those scenarios. And the questions were pretty intentional. I wanted them to tap into different views and then also justify them. So I'm not just using it because, but when are good times to use different views of the functions. And so why I like it or why I do this is there's not a procedure. You get a lot of reasoning and sense making. You get some really awesome discussions as they move the cards around and kind of debate with each other which view matches with which graph matches with which equation and whatnot. And so it's a great lead-in to functions. It emphasizes those four views and the connections. And then what I really see is students value the view of each function, and then they're most apt to use all of those views going forward. They're not just stuck always looking at that equation. They're much more flexible. So you could do this with some specific functions. I've done one with exponential functions. And then I'm also trying to always update the scenarios with realistic and current data so that it's relevant and tapping into their interests. So if you have any questions, feel free to email me. I'd be happy to share the activity.
Yeah, Brianna! Your entrance ticket.
All aboard!
Yeah.
Exit tickets for extra credit. My name is Brianna McGinnis. I'm from Carroll Community College, which is in Westminster, Maryland. I'm the only one that came from there. I have a lot of experience with transitional mathematics, but I also teach on the credit level side, pre-calculus as well. I coordinate transitional math, and this presentation I mostly use in my transitional math courses. There was a dilemma. So I'd start my class, we'd go over homework questions or do a warm-up, and I'd have my lecture, and I'd say, okay, well now we're going to practice, and here's this worksheet, or you're going to hop on your computers, or we're going to do this such and such activity. And students would leave early. So the solution is exit tickets. At the end of class, the last 5 minutes, they take out a half sheet of paper, and I ask them 2 questions. And the answers to the questions, if they're correct, count toward their extra credit total for the semester. I used to make sheets myself, but now I make them use their own paper that they cut in half. And again, it's the last 5 minutes of class. You really only may need 2 or 3, depending on the nature of the questions. The majority of the time, the questions are, they can use their notes, their book, but they cannot use each other, and they cannot ask me questions because it is extra credit. And they have to show their work. They cannot just put the answer because we're getting ready for the quiz or the test. Each question is worth 1/2 of a point, and so they can earn up to 1 full point of extra credit per day. And as a department, we have a 2% extra credit policy, so they can only get 20 points total, depending on our points. So it's accountability and incentive for them to arrive on time, because maybe that question you answered at the very beginning of class. For them to take good notes, since they can refer to their notes while they're answering the questions. For them to pay attention and not be texting or on Facebook during class. For them to ask questions because they know, oh, the exit ticket question might be related to this, so let me ask. And then for them to stay the entire time and not to leave early when maybe we're going to be practicing and doing some interactive activity. It's informal assessment, and you can also get to know your students a little bit more. So these questions don't have to just be math related, and I'll give you some examples in a minute. So most frequently, I give questions that come from the lecture. They're basic in nature, or at least I think so. I'm sometimes shocked when I get the exit tickets back and they were completely wrong. But most of the questions, especially if you cover 2 sections, are from that. Or you can ask them to just copy the warm-up problem. Again, incentive to get there on time, and they cannot collaborate. Or you can ask just an informational item. When's your quiz due? Or when's the next test? Or what is today's date, for God's sake? But to get to know your students, you could just make it fun and say, what's your favorite food? What are your plans for the weekend? What did you do last weekend? What's a favorite hobby? Just anything to lighten the mood. It's going to be extra credit. So, okay, so this is a student example. I know it's probably hard to read, of a perfect score, a +1. These are logarithmic expressions and an equation to solve. And so they got a check mark. If I'm feeling happy, I'll give them a smiley face, but this person got a +1. This person got a +0.5. They got 1 out of the 2 questions correct. I tried to correct them if they were wrong and give them a hint and tell them what the correct answer was. And then the next one will be a +0, which does surprise me sometimes, but again, it's formative assessment, and again, accountability for the student. So I've corrected it. give them the correct answer. You might want to make a note, please see me for extra help. This is how I keep track. This is actually my attendance sheet, and the little 1s and 0s and 0.5s that you see to the bottom right of the check mark, that's the score for the exit ticket for the day. The empty boxes are if they were absent. I don't give exit tickets on test days, but I do on lecture days and also review days. You could vary this by giving an entrance ticket if you have a flipped classroom, or you want to give almost a homework quiz, so to speak. The only drawback is the time that it takes. Since most of us are at community colleges, we have fairly small classes. I don't mind going through quickly and grading these. So if you're willing to put in the time, it is worth the reward. Give them a try. Thank you for listening.
So I'm Rob Eby, aka Button Guy, and all this will be repeated at the end of this. And I want to talk to you about why your students and mine do not understand graphs. So first of all, have you seen this graphic that's sort of floating around on Facebook and sort of this popular sort of a thing that goes around here?
Yeah.
Fred, the music's not playing again.
Yeah, I know, I tested it.
So I hate love because I graphed all 4 of those equations on one set of axes, and that's not love. That's a mess. Okay? And so yeah, you're missing out on all my favorite songs that are in the playlist on the back.
I know, Rob. God.
So that's love. It's a 4-letter word. Okay? And I dare you to give your pre-calculus students just the graph and ask them to come up with the equations. They would agree that love stinks at that point. So, the wind beneath my wings, I got onto this first with this article in Primus. What they did was they discussed some of the issues in their assessment, and I want to compare how they did, how my students did, and how my students did this semester. So, for instance, this semester, so the red, I normally get the first week of classes, that's the blue. This semester I waited until a month into the semester to see if I could make something different happen, and apparently I screwed them up. So, lesson learned for me there. Slope triangles, this should be easy, right? Well, a quarter of my students tell me there's no way you can determine the vertical segment of this problem. Calculus 1 students. Yeah, we have a problem, Houston. Well, right, College Station. If we confused solutions with roots, there's a large number of my students who think that that's not a solution to that equation because it's not on the horizontal axis. Oops. We have a problem. Lines? Yeah. It's a constant function according to most of my students. After we've talked about increasing, decreasing functions. Again, several of them have a problem with this. They may be digital natives, but they're digitally clueless, in my opinion. And we have to help them with this. In particular, you're killing me on this music.
I know, I'm so, but it worked.
Yeah, that's what, yeah, your dog gets your homework too. Look, the biggest cause for this was 25% of my calculus students says it doesn't matter which direction you read a graph. This is pretty consistent across the semesters. Oh gee, no wonder we don't talk about increasing, decreasing correctly. We're not going the same direction. So we need a new, what I think is a new education, and I stole this from another Ignite talk many moons ago by Alex Landry. The title is called Chart Wars, and it's not quite safe for work. There's a couple of words you might want to listen to it first, and right now you hear the theme for Star Wars, of course, because it's obligatory. That's the right song. I'll spare you trying to hum it because I don't quite get the tune right. But there you are. And so he talked about the pictorial superiority effect. And so what is the pictorial superiority effect in there? And the idea is basically if you match a picture with text, the retention rate after a couple of weeks jumps magically. And at this point you hear the Queen song, it's kind of magic, but again, I'm so put out. Oh, sit down. Don't worry about it now. Okay. So also, there's a great book, and well, I do too. And there's also, if you go to the website here, they summarize the book or the chapters. Use this visual brain, this brain information to encourage and affect how you form your lessons. Now, some of you are thinking, "Ooh, visual learning, visual learners," and I'm a tactile learner. I got news for you. The best research indicates that's a load of bunk. Now, that's a very profitable and popular idea in educational circles. I realize that. So on my blog, which will come up at the end, I have several links to the professionals who study this for a living about why they think this is load of bunk. But it's doing some harm to our students to say, oh, well, they're just a visual learner. They can't possibly move symbols or other sort of silly mess like that. No. Now, some subjects work better with certain visualizations versus other things. I would not want to do geometry without drawings. But that's another thing. Quarter of my calculus students this semester said, oh, there's a min at x equal 1 because the graph goes down and up with the equation shown. You and I have no problem seeing, it's not just whatever, here's that autoplay. Use color. You and I have no problem seeing the difference between the parabola and the axes. Our students don't. This is a mess of lines. Use the color to make it pop out for them. In particular, so with the question, the slope triangles, I just put that on the screen. And they said, oh, the color pulled it out. Say? So, make efforts to help your digital natives, well, become digital cluey, or clueless. So there's my email if you want to workshop in the document. Everything that I just talked about, including all the links, is on my blog. Thank you.
Okay, a brief pause while Mary Beth opens up the second